Good afternoon. I'm Nancy Koos, K0NKK. I'm with Eduspace Science. I've been with Eduspace Science for a little over 6 years now. We're talking about the last 174 flights. I've been around for the last 113, so I've got a little over 100 flights in my belt. Jim.
And I'm Jim Langsted, KC0RPS, and like an idiot, I volunteered to be president last year for EOSS. It's almost a full-time job. But I selected the last 174 flights. Oh, I've been doing this about 20 years, I think. 174 flights. Why? Because that was something I could bite off and chew. That is how far back our current website goes, so I could access stuff fairly easily. Tomorrow we'll be flying flight number 378, so there's quite a few more than this. Clicker. There we go.
Things to come. Pictures from altitude, some of the GoPros that we've had. Pretty amazing pictures. We're going to talk about our payloads, we're going to talk about launches, we're going to talk about waiting, and we're going to talk about landing. Flight 234, students took this. The Earth is round. This is my next to favorite flight. The two white squares on the lower left is the actual balloon, so this is right after the balloon was cut loose.
People say that the parachute up at 100,000 feet doesn't inflate and bite in. Can we back up at all?
Yep.
Doesn't bite into the air. You know, obviously it doesn't bite into the air because it's coming down about 60 miles an hour, but that parachute looks inflated to me.
The puff of talcum powder. The inside of the latex balloons have powder in them, and that's a pretty cool example of the balloon bursting and the powder puff. Students who have a lot better eyes than we do say they've actually seen a puff, because we'll be out there looking at 100,000 feet, and you can see this little white thing, and then all of a sudden it's like a puff and it's gone.
Kind of the ghost of the balloon.
Yeah.
For tops.
Yeah. It's cool. Shards falling down. Balloon. Look at big shards falling down. Oh, what did I say about this one? We're going to talk about that white thing and that black thing in the lower bottom later on in the slides. Okay, here's some of our payloads. This is from NDIA, or National Defense Industrial Association. Norm Black usually launches twice a year. And he has students from all over the United States. It says Wyoming schools, Cozy, Hollow, and Antelope Creek. So it's a very small town in Wyoming. Was actually the students were involved in this this launch.
I think those are one-room schoolhouses too up in Wyoming.
Yeah.
What Norm does is really neat. He contacts these schools. The students put together experiments in, he used to cut ping pong balls in half, but that was too much work, so he uses Easter eggs now, the plastic Easter eggs. Kids send the package in. He'll package these up in a big payload like that. And he's in 3 of those payloads, he says he represents 2,500 kids doing experiments. Then he mails the experiments back to them, and then he's also a videographer and puts together a video that the kids get to look at about how the whole experiment went.
This is some of our students checking their payloads. For a while we had access to a school so we could string our payloads inside where it was warm. And this is an example of students turning their payloads on before they were strung.
And then we had an incident with smoking in the boys' room. And it set off the alarms in the school at 6 a.m. and it automatically calls both the principal and the superintendent. So after that, we have to set them up outside.
We still can use the inside for the bathroom, but we can't string inside, unfortunately. Okay.
This is yours.
This was an interesting experiment. You know, most of the time, when we're servicing student organizations, these black boxes come, which are the student experiments. If we ask them, they'll tell us what they're doing, but they're too busy getting everything set up. But this was an experiment that we flew for the Laboratory for Atmospheric and Space Physics at the University of Colorado. And this was a large payload that we brought up on a 3,000 gram balloon. Next slide. And we did learn a little bit about the science here. What this is a 1 kilometer long fiber optic fiber that they reeled out of the bottom of the payload. The idea was that they want to go down into southeast Pacific Ocean, where I guess 80% of the moisture in the world evaporates from, and they want to measure the temperature gradient in the troposphere. And so what they do is the idea is bring this up in a balloon, lower the fiber down, and then they can shoot a laser pulse down the fiber, and there's something called Raman scattering that they can measure the reflection coming back up from the laser pulse and determine the temperature. Next slide shows that it was quite successful. I think the blue one is actually their measurement. The green one was measurements done with another temperature sensing system, and the red one was the radiosonde that was launched that day. So they were very pleased with that result, and I think that experiment has gone down now and been deployed in the South Pacific. So that was kind of some neat science.
This is some of the payload packages that students have come up with. I just randomly picked out ones that I thought were really kind of interesting or different. This is from Ball Aerospace, Ball Burst. We launch interns once a year in the late summer. Sample of one of their experiments. Where it landed on its side. One of the professors charged the students to do GoPros that were stabilized, and this is an example of one of the experiments that would stabilize the GoPro camera. Whoops, missed one. Norm's eggs.
Yes.
We had a little oops when it landed. This was an experiment that was done by grade school students. It's a hula hoop with balloons on the outside, and there's measurements. I think the balloons were filled at different sizes, and they could measure from the GoPro camera how big the balloon got, and then when it retracted again. Okay, when we were looking at one of the first photos, we had a black thing and a white thing. The white thing is obviously a marshmallow. When we were getting ready to string the payloads, it was on a chopstick. And the FAA is really concerned about something that we launch that can come down and impale something on the ground, be it a tracker or a cow or nothing. So we just globbed black electrician's tape to blunt the force of the chopstick. It's a fun experiment. They also had a GoPro that was looking straight out at the marshmallow so they could watch it expand and collapse. Oh, yeah, you talk about you land and then you've got to get landowners' permission. And sometimes that takes 5 minutes and sometimes it takes a couple hours. Well, this is an example of students who had a sugar water experiment. And by the time we were able to go pick up the payloads, the ants had already gotten in there and contaminated everything. How to keep a payload balanced. I wasn't there for that, but it looks like it was a fairly...
I think this was a downward-looking camera, and they were trying to stabilize it. This was during the 2017 eclipse. and try and take a picture of the shadow from 70,000 feet.
Cool. Oh, this is another one trying to balance the GoPros to keep the GoPro steady. Interesting designs. One with fins on it.
Okay,
Look at
you know, we've talked a couple of examples of trying to fly back to the landing point with our payloads. National Weather Service decided they wanted something that could fly their samplers back to the landing point. So through a contract, they had developed a actual glider. And this is a glider without the wings on it, but pretty big thing. And we hauled it up, you know, with a 3,000 gram balloon, probably 70,000 feet, and then released it. We had to get permission from the FAA for a waiver to the do not release requirement. But one thing, we've always kept a good relationship with the FAA, and when things like this come along, we've had pretty good luck. Next slide. The thing was fairly successful. It came back down. It was hung up on a barbed wire fence there, but they retrieved it and were successful with that. And I did follow up on that, and they did take it down to White Sands and flew it down there, and were successful in returning to the landing site.
What did the wing look like on that?
Oh, they were, it was a composite, or styrofoam and fiberglass wing, a normal Bernoulli shape, probably about 5 feet across.
Like short and stubby or long glider? Or?
I think they were pretty long. I think they were 5 or 6 feet tip to tip.
We have a set of instructions that we give to the schools and ask them to kind of follow what we require. And one of the things we require is they use a through tube, like a toilet through tube, that we can run the flight string through. They kind of missed. And they 3D printed this, and they had a hole in it that was about this big. And the flight string is tiny, tiny. And so we were talking about, okay, this hole is just a little bit too big. And so I run and grab a piece of wood, and I'm going, oh my God, you're just going to mess up all my calculations, and the balloon will never go up. So we ended up getting rid of the wood, because obviously we weren't going to fly with that much additional weight, and did modifications. There was another one who didn't do the through tube, so we did a through tube on the outside of the payload. On that red one, we ended up running payload string through on 2 of the smaller holes on the side, and then doing the
Bridle?
Yeah, bridle with the release clamps, or I call them D-rings, quick links. Oops, wrong way. Oh, anybody want some s'mores? Yeah, students do all kinds of things like ice cream. I guess nobody ate the ice cream because it was in a 3D printed container, and they didn't know if there's any contamination from the 3D printer. We've had chocolate bars. The kids actually ate the chocolate bars and said they tasted terrible. So I don't know what happened to those.
Desiccated.
Yeah. Trying to cook pizza rolls and making popcorn.
They thought popcorn, if they flew the popcorn up there, the low pressure would make it pop. But I think you still have to have a steam explosion inside, so it wasn't successful.
We had a little bit of semi-success with that experiment.
Yeah.
Did you?
We had a quick release, so it was at ground pressure until it quick released. Test tube with a heater around it, so it was about 150 degrees or so. It didn't pop, but we did have some kernels that cracked.
Okay,
Okay,
we'll pass that on.
tempting.
Yeah.
Blew a banana once, and looked like a banana that had been in the refrigerator for a whole year.
Oh.
It was all brown and mushy.
Didn't have much appeal.
No.
Okay, launch photos. That's always my favorite time. Get any better than that? Perfect launch. Everything goes up, stringing along straight up. Oh, yeah, then you've got to watch for airplanes. We do a lot of launches from Lyman, Colorado, and there's an airfield out there. And since we launch pretty close to sunrise, there's a lot of pilots out there doing touch and goes. And it seems like they're touch and go, and then they kind of try and figure out what's going on at the ball field, and they see our balloon and head way north and stay out of our way. Oh, yep, going down the flight string, making sure all the payloads, student payloads are turned on, students know how to hold the payloads, all the knots are correct.
Student participation.
Yeah, especially that one on the far right who has the bottom payload and needs to make sure it doesn't fall on the ground or touch light poles.
Right.
Right, yeah. Oh, there they are all lined up. Those are demostat payloads. They're all very tiny, small.
The University of Colorado during pandemic developed a program where they would mail to an individual student a package, and it included a soldering iron and some foam core and a circuit board and an Arduino, and there was a series of video instructions on how they could put together a payload, and it did environmental monitoring, temperature, pressure, humidity, as it went up, and then the students could send these back in. And so we had 2 or 3 launches during pandemic where it was just a few of us launching these. In this particular situation, a lot of students were able to come out, but a whole bunch of identical payloads, but it was a neat program for students to still be involved.
There, Larry did the 5-second countdown. He releases the balloon and pop, pop, pop. Sometimes we launch it in a straight line. Sometimes we launch in a U shape. It depends upon the winds, what direction the wind's going, and how many students we have.
What are the maximum number of payloads you've ever had on a string?
Probably 20 of those small payloads. Normally, our big balloons have about 10 1 kilogram payloads.
Yeah. I was doing the payload plan, and my flight string was over 100 feet long, and I'm going, no, I can't do that, and that's because I was still doing the 2 feet in between the demostats, and we took that down to 12 inches. Yeah, it was just too long.
Okay, so I looked back over the last 180 flights that we've done. I couldn't find information on 2 of them, so there's only 178 there. But looking at the number of balloons that we've flown, and you can see, a 600, a few 1200s, but primarily the workhorse in our program have been the 1500 gram balloons or the 3000 gram balloons. And we've flown almost an equal number of the 3000s or the 1500s. The way our program works is if it's a 3,000 gram balloon, that's non-exempt. And one of the requirements for non-exempt is you can't fly in airspace that has more than or less than 5/10 visibility. So if it's cloudy, we can't fly 3,000. So what we do is we go out in the morning, and if it is cloudy, then we have to split the payload string into 2 1500s. So we might go out one day expecting to fly 2 3,000 gram balloons, end up flying 4 1,500 gram balloons. But over the years, it's just about equaled out the numbers. And one of the questions I asked is, how often do we achieve the predicted altitude, the burst altitude that we're used to, or that we come up with? We use the algorithm that's used in ABHub for estimating the the burst and the manufacturer's information for burst diameter for the Totex balloons. But you can see for the 1,500 gram balloons, on the average, our balloons make it up to about 95% of what we promise them we'll get. And of those 1,500 gram balloons, only about 38% of them actually make it up to the burst altitude. So either that's something defective in our algorithm, or the balloons aren't quite as high quality as our parameters indicate. For the 3,000 gram balloons, it isn't quite as good. On the average, our 3,000 gram balloons make it up to about 91% of the predicted burst altitude, and only 16% of the balloons that we launch actually make it to that burst altitude. I'll show you a graph later that's kind of indicative of what's going on.
If they don't make it to the burst altitude, what happens to them?
They burst and come down lower. You know, like we calculate, for example, that this balloon will go to 102,000 feet. 100,000 feet, in my mind, is a kind of neat place for students to get to. So we predict it's going to go to 102,000 feet, but it bursts at 91,000 feet. Okay, it just comes down, and actually the prediction is a little bit shorter than if it had gone up to 100,000 feet, so our prediction people have to move back in a little bit. But other than that, not much. Next slide. Oh, this was a great adventure one day. One time we thought, we had a whole bunch of schools, and we thought, okay, we can launch 3,000 gram balloons and get all of these student payloads up there. And if it's cloudy, we will have to go to 6 1,500 gram balloons. But we could do it. Marty's back there trying to shoot himself. But we thought we could do this. We had enough equipment, enough beacons that we could put, 2 APRS beacons on each of the balloons. So we went out there and said, how are we going to do this? Well, we'll launch the first 3, and our trackers will go out and track them down and recover them. Then we'll launch the next 3. And so we started in the morning, and we launched the first 3, and then while the tracking and recovery people were out there doing that, and we assigned people to specific balloons, they started getting the second set of balloons together, and the wind was picking up. We always try to launch at dawn to keep the ground winds as low as possible, or that's when they are the lowest. And anyway, the wind started picking up, and I guess Larry can attest to the fact that they were wrestling with balloons at 10, 15 mile an hour winds. And I remember I was out in the field, and they said, oh my gosh, one of the beacons on our second set of balloons isn't working. You need to take one off the first set of balloons and bring it back to us. So I got in the car, and I was roaring back, and then they called on the radio and said, no, we got it working, so you can go. Anyway, so we only did that once in our life. We promised ourselves we would never do more than 4 at any one time. And now we only have enough equipment to do 3 at any one time, and there's no big push to increase that. So
Yeah,
that was a great adventure back in, when was that, 2017?
We have a question in the back row.
Yeah.
I'm just going to add just a couple of notes. One of the things is when you've got that many balloons in the air, especially after the first set, because you're tired from finding all this stuff out, you end up not sure exactly, because they all kind of land close, so you're not really sure you know which balloon it is. Like we were picking up balloons, we thought, oh, this one, there's the balloon right there. Okay, we got that one. No, that's not the one you were looking for. So everybody else is looking for that balloon. You've got it in the back of your car, and somebody else is looking for the other balloon. It was a wonderful experience.
A learning experience.
We
A
only did
very big learning experience.
Yeah, I actually filled 8 balloons. I lost 2 of them during fill.
Because of the high winds?
To get the set because of the high wind.
Yeah.
That says something for the reserves that he keeps on hand in case of
Yeah, when we go out to launch, Larry always has an extra balloon and extra gas, enough that if we do lose a balloon, we can keep going. Next.
Oh, waiting. That's yours.
Okay, this was another great adventure. You know, you can look at the weather predictions and pretty good predictions that it's going to be windy. Not quite as good of predictions that it's going to be cloudy, but if it's going to be fog, that is a real surprise to us. So we deploy everybody out to the launch site. You know, most of them have driven 70, 80 miles to get to the launch site. And we were going to set for an 0700 launch, but it was cloudy. And we have a requirement in our waiver that 5-mile visibility. We need to verify that there's no planes within 5 miles of the operation. So we're stuck. We're sitting out there at 7 in the morning, no fog, all the students there. We haven't filled the balloons yet, but so we look at the weather forecast, and the weather forecast says that fog is supposed to lift by 0900. Okay, we can wait 2 hours. So just stand around, sit around, and then at 0900 it's still foggy. So we contact the FAA and talk to them again. The FAA has always told us we would like you back on the ground by 0930. And that's because DIA airport traffic spikes right around that time, or just after 9:30. So we contacted them, and they said, could you please hold until 11:30? Okay, we'll do that. So we all went and had breakfast, came back at 11:30, still foggy. We decided we would wait until 12 or noon, see if the fog is starting to clear. Things are looking a little brighter, so we said we'll wait till 12:30, then we'll wait till 1 o'clock, and then 1:15, and we finally said, okay, we'll wait till 1:30. And finally, at 1:45, fog lifted enough, we could see something 5 miles away, and we said, let's do it. So at 13:58, 2 o'clock in the afternoon, we finally launched. This was the longest time that we or any of the students ever had. We stood out there for 7 hours waiting for the launch, but since we had everybody there, we could send them home, say we'll do it another day. No, let's stick around and try to do it. During that time, one kid tried to knife another kid, so we had to deal with that. And we also, one group of elementary schools, they had some, African hissing cockroaches. They're about 4 inches long.
Yeah.
And they had been trying to fly these for a number of years, and they always froze and died. So they tried putting hand warmers in it, and it didn't keep warm enough. So here they had them this
Did
time.
they find hand warmers small enough for cockroach hands?
Yeah, little tiny ones. So what they did is they had a thermos bottle, and in the thermos bottle they had the cockroaches. I think they had an air vent in it or something, but they had a hand warmer in it and everything. They had a temperature sensor in it and everything. But when it sat for 7 hours, those poor cockroaches got up to 160 degrees in the thermos bottle, so they didn't survive. Fortunately, they had some control cockroaches still in the car. They were able to put those in, fly them. They did come back and survive, but that was a treacherous day. Yeah.
Okay. This was this year, Colorado State, space grant. And we had to cancel the first flight because of bad weather. We went out for the second Saturday, and we ended up with fog. And we were going to wait for the weather to clear, and all of a sudden we were losing GPS locks on all of our beacons.
Yeah.
And in talking to the FAA, several of the tracking satellites, the GPS satellites from White Sands and Yuma? Yeah, from White Sands and Yuma, were recalculating all their satellite positions. So therefore, we had to cancel the launch for the next week. And unfortunately, that was finals week, and we only had 3 students show up for that. The rest of them were taking their finals in this class, with their final papers due the next Monday.
And as the flight coordinator, I had the honor of turning to all these students who had drag their sorry asses up at 0400 in the morning,
Yeah.
come out to the launch site that, no, we're not going to be able to launch today, you're going to have to go home.
Yeah.
So,
That was really bad. We lost GPS lock, so if any of us had the experience of tracking in the olden days, we could have gone ahead with the launch.
DF,
DF,
that's right.
after the fog lifted.
We could have done that, right, you guys?
Yeah.
What's wrong with you guys? Some showed up in their homecoming, or their
Oh, yeah.
prom suits and.
Kids had had prom the night before. and
Oh, God, those are
they, of course,
awful.
stayed up all night, and they showed up in gowns and tuxedos
Yes.
for the launch that morning.
So we've got a tracking team, and the tracking team goes out and has breakfast, and then we've got the launch crew, and the launch crew hangs out at the launch. So on this particular day, the trackers were at lunch in Greeley, and we contacted them and said, okay, we're on hold, so they stayed at the restaurant, and then we canceled, and we met the trackers at the restaurant. So it's one of the few times that the whole EOSS team has ever had a meal together on a launch day. And I think the trackers were there for like 3.5 hours in this restaurant, but we tipped them
A lot
well.
of coffee.
Oh, yeah, a lot of coffee. Okay, redundancy, you need backups for everything. We do have a van, we call it our mobile ground station, and our van is currently out of commission. So we did have the original ground station, which was tables and computers and antennas set up. So we used this at a launch a couple weeks ago.
With our program, lots of the school programs, the busy time of the year is the end of the semester, right? Because they've been building payloads all semester, doing their classwork. And unfortunately, the end of the semester falls end of December, or end of November. So it's often cold. And we've got students out there in 20-degree weather standing around. We always try to tell them stay warm or dress warm, but it doesn't always work. Usually no flip-flops this time of year, but.
Yeah.
Okay, so looking at all the last 180 flights, all the various programs that we have supported, the top program, NDIA, that stands for the National Defense Industrial Agency, and that is a industrial group in Colorado Springs, and they sponsor Norm Black to do that Easter egg program that he does with all these kids. And over the last 10.5 years, we've flown 20 balloons for him, carried 50 payloads for him, and he says that he has touched 12,700 students in that program. One time we went out to Koos, actually we've done it twice, but only in this analysis. One time we went out to Koos Field. One of the TV people in Denver has a science segment. He arranged a STEM science program. There were 10,000 students in the audience out there, and we flew a balloon for them, and they tracked it on the Jumbotron, everything. Then Colorado Space Grant Consortium, which is NASA financing aerospace programs to get aerospace students. We've launched 53 balloons for them, 341 student payloads. Each is a team of 5 or 6 students. So there's 1,700 students there. Coincidentally, at Coors Field, there were 10,000 students in the audience. And then high school programs. Metro State University has an Intro to Space program. Gateway to Space is a CU Boulder aerospace program. But over all of these, the total is in 10.5 years, about 27,000 students, I think we have influenced. And hopefully some of those went into aerospace and graduated, vice versa.
I'm sure they did.
Yes.
So what does it mean when EOSS has 12 balloons with no payloads? Larry?
Well, it has happened.
Okay.
That's not included.
No, those are 12 balloons where we were doing qualification flights and
Oh, I thought
everything.
those were 12 balloons that got away from them.
Probably UPSL as well.
Yeah.
We've recovered every balloon and,
But
well,
I'll
not
add
balloon,
those,
payloads,
Mike, I'll add
Every
those to the
payload.
list.
every payload.
Every payload.
This is one of my favorite pictures. We're out at the rendezvous, and the students are watching the balloon at 100,000 feet. It's that white dot up there. I think it's super exciting. I think it's more exciting than watching the parachute come down. But there they are watching that balloon up there.
I'm watching it first.
And yeah, if you're looking at it and all of a sudden it's gone, it probably burst, or you blinked and you lost it. Oh, this was Lyman. We launched at the softball field, and the prediction had the balloon going up and around and around and around, and it was going to land within 15 miles of where we launched.
Kind of like tomorrow.
Yeah, like tomorrow. So we just kind of hung out at the baseball field because it had bathrooms, and a bunch of people went into town, had breakfast, came back out when the balloon burst. We had enough information to go out and track. Fun time. Oh, let's talk about landings. Isn't that perfect? Absolutely perfect. Everything's just laid out beautiful. That's all the demo stats. The parachute's up at the top of the screen. And then sometimes it doesn't. Everything was kind of a muddled mess on top of the parachute. In the cornfield, of course.
Okay, I took a look at, this prediction, how often do we make it up to the altitude, so I plotted all those out. And this is all 180 balloons, predicted burst on the x-axis, the actual burst on the y-axis. But what sticks out there are some outliers. What is this one down here at 11,000 feet? You go to the next slide. You will see that what this was EOSS, GPSL, I don't remember what year that was. It was EOSS balloon number 300. It was a GPSL, a virtual GPSL during the pandemic. And we were supposed to go out and launch a balloon, and everybody else launched a balloon, and we had video coverage of it and everything. Winds were 19 miles per hour, gusting to 25, so it was a miserable launch. We went ahead and filled the balloon and launched it. Next slide. It had very little lift because we've been fooled by the wind into how much lift we were actually putting in the balloon. It floated over, caught on this fence, sat there blowing on the fence. We ran out, grabbed it, brought it back, put more gas in it. As we were putting more gas in it, we realized it had a pinhole in the latex, but we weren't going to deal with it at that point. So we went ahead and launched it. And when we launched it, let's see, next slide, I think takes me back. Well, when we launched it, it only went up to about 11,000 feet and then slowly came back down.
And that was launched from an Atlas missile silo base.
Yes, one of the old.
Taken apart many years ago.
The silo is actually gone or filled.
I think it was one of those horizontal landings.
Okay.
Like the one
Yeah.
across the street.
Yeah.
That's why there was no
Yeah.
silo.
Okay, so here's a blow up of that previous graph that I showed you. The yellow dots are the 3,000 gram balloons. The blue dots are the 1,500 gram balloons. The green line is if it is predicted to go to 100,000 feet, and it does go to 100,000 feet. So if you look at the 1,500 gram balloons, you can see that's a pretty relatively tight cluster around the predicted launch site, with the exception of some outliers that fall down below. And I'll be danged if I can figure out what causes those to burst at lower. altitudes. You know, we've looked at weight, we've looked at age, we've looked at, stress on the balloons. But the 1,500 gram balloons seem to do pretty well. The 3,000 gram balloons, look at that's a much bigger spread. Very few of them making it up to the prediction. Few outliers at the bottom, but a bigger spread. Trying to think what could possibly cause this, and one of the things is the weight of payloads that we put under these balloons. You know, if you go to Totex and say, we want to buy a 1,500 gram balloon, how much weight will it carry? They say 4 to 6 pounds. And on the average, for a 1,500 gram balloon, we hang 13 pounds. Instead of 4 to 6, we're hanging 13 pounds under. Maximum we've hung under there is about 16 pounds. So stress on that, stress on the balloon, but fairly tight distribution there. With the 3,000 gram balloon, Totex says 4 to 12 pounds. We, on the average, hang 20 pounds underneath one of those balloons. The highest amount we've held is we put under there is 26 pounds. So a lot more stress on that balloon than the manufacturer is expecting. Possibly that's it? I don't know. Okay, next slide.
Okay, this is us taking the students out. We get a lot of students. You figure average of maybe 4 students per payload, and they all get up at dark 30, come out, and of course they want to hike out to get their payloads, which might be really close or it might be up to a mile or more. And it's never just flat rolling grassland. It's always yuck.
But there's no trees.
No trees, not even one. Okay, there I am. I don't understand college students because I ask them to count off and I'll go, okay, 1, 2, 3, and then I'll go 1, 2, and I can't count to 3. So I'm out there counting every student as they go by, and it was up to 59. We need to count how many go out to make sure we have 59 come back. And then there's always a couple EOSS people that are trying to sneak by and not get counted. We might leave them out in the field next time.
And it never works. We count out how many people go out, and there's 53. We count how many people come back, there's only 52. Okay, what's that mean? Did we leave somebody out?
Yeah.
Never works.
Yeah, especially if it's like rolling, a little rolling, and the payload's over two small hills. Sometimes we'll leave one of the EOSS people at one of the hills so we know how to get back to the cars. Oh, this was a fun one. We landed at a wind farm.
My nightmare is someday we're going to land and the payloads are going to be up there going wop, 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 around. We'll never get them back.
Yeah. Oh, sometimes they land on power lines.
We don't have trees, but we do have power lines.
Yeah, so we just kind of stand there and wait. Actually, there was a house across the street, maybe a half a block down. Only it was a county road, and they knew personally who the electric company was and the guy to call, and he got in his truck and came out, set up everything, and got our payloads down for us. Trying to keep the students away from the payloads was also difficult. They want to see what their results are. Open up the pack. Nope, can't do that. Wind, anybody talking about wind? So everything comes down, parachute's open, parachute gets caught in the wind, and everything gets drug across the ground and into a fence. And it's banged up against the fence post and the barbed wire. It's one of our payloads, unfortunately. Oh, on launch, as careful as we are and as careful as the person is who's carrying that bottom payload, this one crashed into a light pole. It's a bottom beacon. The poor student that carried that was nervous that he did something wrong. We assured him, no, you didn't. But payload went up. We went to ground station and it was sending So we knew it was still good. But that's the damage the light pole did. Okay. The reason we have a quick release is on the balloons is because of that mess. Anybody know how stinky that latex is? Yeah. Yeah, anybody want to put it in their car to take back home? Oh, that's why we have students. Ask the students to take it, yeah. So that was one of our messes. And another one, and that's the release in the middle of that balloon. Shards of balloon. And then we have Mabel. Mabel was out there. Mabel was wonderful. Could have cared less that we went out there. We've also landed in a field where the cows were calving. I think one EOSS person was allowed to go out on a four-wheeler with the owner to pick up all the payloads.
Oh, and incidentally, the story Bill was telling about the buffalo field, my version of it, slightly different, but we arrived at this buffalo field, you could see the payloads out there. Our guy said, no, let's go get it. So they jump over the fence and start to walk out in the field to pick up the payloads. The rancher came roaring up in his ATV and he said, if I were you, I would get your people out of that field. And he says, I've seen those buffalo push pickup trucks over before. So then he went and got the buffalo treats and they recovered it that way, but.
Yeah.
Tipped over pickup.
Yeah. They're not nice. Okay. Sometimes students walk in a straight line. It looks like we're bringing back all of our payloads, so we've got a nice little road to follow. Still watching for rattlesnakes, cactus, and holes in the ground. Oh yeah, that was grassy, hard stuff up to here. Not fun. We try and check out all the students to make sure they've got the appropriate clothing. No flip-flops, no Crocs, well, I guess shorts are sometimes okay. But yeah, it can be really dangerous out there, especially with snakes and cactus. This is another fun one. Bringing the payloads back in. I like the smile on the girl in the front. Some landowners are really, really nice and let us walk out. Some landowners prefer that we don't. And this is an example where the landowner did not want the students going out across their property for whatever reason. So they allowed a couple EOSS people to go out, pick up all the payloads. We just pick them up and then take them to the road and lay them out in order so the students can see them. We don't cut anything apart or turn them off, whatever. So I don't like doing that, but we want to keep the landowners happy. We want to continue to launch and retrieve. Successful recovery. It's always fun pictures. Another one out in the field after they've got all their payloads. Oh, yuck. Sometimes the weather's nice, sometimes it's a little snowy, sometimes it's really, really muddy. Yuck. Trying to clean up everything. And of course, we don't want to get our cars dirty.
Those were the boots. After they came
The
back.
trackers, yeah.
Everyone bring their boots for tomorrow?
Yes. Thank you. Any questions, comments? Excuse me.
It's just some of our adventures over the years.
Thank you, Jim and Nancy. Much appreciated. All right, we're scheduled for a break we're scheduled till 3:15. Do we want to go about 3:20? Work for you guys? Get back in here about 3:20?
Thank you.